So I want to use a library called CSE8ACSV. So common separated value. It's another library similar to the image library. Except this one processes CSV files. And we're going to look at two data sets, two actual real world data sets. The Black Lives Matter data set is data that was taken from last year about the protests that were happening in the United States. And this other one is data from last year about the diversity in tech, in the tech industry, the diversity of different races and genders in the tech industry. So first, let's take a look at the data. And I have, let's look at the BLM right here, the BLM state. And this is a comma separated value. You can actually see it has a CSV. I have my extension showing, which is why you see extension. But if you don't know what type of file it is, it says comma separated values. And we can open this up with a text editor, but that's pretty long. So I would prefer not to look at it in a text editor. You can also open them up in a spreadsheet. So we have state. So, and then for each state, we have the poverty rate, the Black population, the Black population's poverty rate, Asian population, the Asian population poverty rate, Hispanic population, Hispanic poverty rate, white population, the white poverty rate, and then the total protests that happened, and then the total attendance of people at that protest. Now, the things that I want to focus on today really are the protests and attendance per state. I want to be able to look up, say, Alabama. How many protests we have in Alabama? We had 6. Actually, I'm more concerned about the total attendance here as well, right? I want to be able to get that information, but we can load all that data and do statistical analysis and such on all that data. So if we have data like this, though, we need to be able to read the CSV file in. This is a CSV file, not an Excel spreadsheet. It's just Excel can open it. Google Sheets can open Excel spreadsheets or CSV files. I want to read this in. I want to convert it into a list of dictionaries so that we can access it. And I want to look at how we can do that. And reading a file is actually a difficult process that's kind of outside the scope of this class. And so we're going to use the CSV library. So if I open, let's see, right folder. So we have this CS8CV, which has a couple of functions in here. Get BLM data, get diversity data, and then get state pops. And we're going to focus for this first example on this function here, get BLM data, which takes a file name. It takes a single file name, which is going to be a file name for a CSV file in the current directory. And it's going to return, notice that it's creating a list. And then it's going through and creating a dictionary. So it's going to create a list of dictionaries. Don't worry about how it's implemented and all that stuff. We're not really concerned about that. And the other two functions, we'll actually look at this one later. This last one we're not going to look at. This is actually PA8. So PA8 is going to use that last one for you. But we're going to look at get diversity as our second example. But for now, we're going to focus on get BLM data. Yeah, let me shut off the weather data. Okay. So BLM data, it's a library function. We don't need to understand what's going on. If you want, you can go and explore it and figure it out, but we only need to know how it works, how the function works. If we call this get BLM data function, it's going to give us a list of dictionaries, and we're going to, for this file that we're going to pass in. So I'm going to create a new file. And save this in our folder called BLM protest.py. And now I need to import our library from CSE8CSV import star, you know, the usual. And now we can call the function from that library. Just to make it easy, sometimes you might want to have both of them open at the same time. So I'm going to call this function. It's going to take a CSV file, right? So again, we have this data as a CSV file. We can open that data. and it's right there, blmstate.csv. Again, we can open it in text, I can open it in a spreadsheet, but I want to open it in our program. And it's, again, it has this data in here. I'm going to look at the first few rows, and we can pull data out of here. In fact, we'll look at some data later as we're running it, but it's going to return something. We actually said it's going to return a list of dictionaries, but let's actually look at it. In fact, let's print it out. I don't always recommend this for large data sets. In fact, you're going to see that Python isn't going to recommend this either. But let's load it all, print it out, save it, run it, and did I not name it correctly? Either I didn't name it correctly or we're not in the right folder. I missed off the A on it. Okay. Oh, what's this yellow text? For those of you who can't read miniature text, that says squeezed text, 157 lines. It's too big. IDLE doesn't like it. So there's a bunch of data here that is not being printed, but it's there. And if we really want to see it, we just double click it. And then we get all of this data. And IDLE was right. That's too much data. I don't really want to see the same thing. But let's look at the top. Let's just see what really happened here. You notice a bracket. Bracket means list. We have a list. And then inside this list, we have a dictionary. We have a curly brace. And we find a closing curly brace. We have a dictionary as the first row. And then we have a comma. And we have another dictionary as the second row. And so we have these dictionaries. And this first dictionary was Alabama. And the second dictionary was Alaska. And so you'll notice, though, by the way, that the first column is the poverty rate. And the last column is the state. And yet, here the first column is the state and the last column is total attendance. So what happened there? Really, whatever we're reading something from a dictionary, doesn't matter. It's just the way it was read in and the way it was populated. The order of these things in a dictionary doesn't matter. Dictionaries are unordered containers. They are data structures where the order of things doesn't matter. But what does matter is the fact that this is a list. And in a list, the position of the elements really does matter. But the elements within the dictionary doesn't matter because you're going to use the key to access them. Remember, to access a file in a dictionary, you have to provide a key. To access a file of something in a list, you have to provide an index. So if I want the state of the first line, I'm just going to provide the key state, and it's going to return Alabama. And this is just how the library works. But because it's a dictionary, we don't have to worry about this ordering of the data. Now, that data is obviously not a good idea for us to print that out. That was not helpful at all. Because it's just too much. In fact, I can't get it to go away. All right. Go away. So we know we have data, but we want to make sense of it. And so instead of printing out the entire thing, let's just do a couple of rows. In fact, if we wanted to print out row by row, which we know is a mistake, let's just print out a couple of things. So count plus equals 1, and if count is 3, then we'll just break. So we're only going to print out 3 rows, just because it's so much easier for us to deal with such small numbers. And so now we print it out. And we get 3 rows. So there's a dictionary right there. There's a dictionary right there. And there's a third dictionary right there. So now we have 3 rows. And so we can see that we have a list of dictionaries. We just printed out them directly, and we have these extra dictionaries. Okay, well, we don't need to do that. Let's do some interesting stuff to this. Well, 3, okay. By the way, to quickly comment something, I'll just highlight it and do Alt 3. So just to make sure what we're accessing, we use that just to make sure we were accessing this properly. Now let's write some functions. Let's write a function to figure out the number of protests that happened. So get num protests. for a single state. So I want to know how many protests for a single state happened for that, that time period whenever this data was collected. Now remember, this is a list of dictionaries. Can we do this? We have BLM data at the top. It has our data in it. And the field is called total protests. If we were to look at the data, it's called total protests right there. So I know what that looks like. Is this going to work? Can we do this? Let's actually run a quick poll. A for yes, this is going to work, if you think this works, and B if you think this is going to fail. What do you think? Is this going to work? Okay. Now remember, I'm going to pass in the state. So I'm going to go ahead and close this. Surprisingly, 7, 8, 8, and 5. So 8 said A, it's going to work, and 5 said B, it's not going to work. If you chose B in chat, tell me why you don't think this is going to work. Why do you think this isn't going to work? So if we were to call this method this is how I'd call it. Why is that not going to work? It's not going to work, by the way. What is our data? Our data is a list of dictionaries. And remember that this is passing in a string. Can we use string as an index into a list? No, it has to be an integer. So if I actually run this, it's going to tell us that, sorry, that wasn't what I wanted to do. So again, we get this error, list indices must be integers or slices. So we cannot access a list using a string. It doesn't work. So what that means is we need to iterate through the entire list, row by row. And then we check to see, now we can look up the key state. Remember, it's called the key is state. Remember, the columns up here are your keys for your dictionary. So the key state. So we look up the key state and we check to see if that's equal to the parameter state. And then we can return from this particular row the total number of protests. So we iterate through every row. We find the row that matches the state, and then we just return it. We don't need to keep going through the rest of it. We found what we're looking for, and so we'll just return the number of protests. So now we get 81 for California. Let's do Wisconsin. Let's do Nebraska. So 81, 19, and 0. Let's go check. California, 81 total protests. Wisconsin, 19. Is that what printed, 19? Yeah, 19 for Wisconsin. And then it had 0 for Nebraska, which is right there, 0 protests for Nebraska. So we confirmed it worked. Now, we don't have time for this, but here's a couple of things that you can do as homework. So get states with at least some number of protests. So basically return a list. And for now, I'm going to return none. Return a list that has at least the number of protests. So for example, if we pass in 10, we should return a list of states that have at least 10 protests, so 10 or more. In a similar function, what about doing the same thing for at most? We'll worry about, you can do this one on home on your own time, but these are interesting things to write to do data analysis. What about at most, let's say at most one protest. So you should have a list that has a 0 protests or only 1 protest inside of it. So you would search through everything and look for 0 or 1 and fill in a list and return the list. You try those things later on your own. And so you just return the state names. So let's move on to, let me save that. I want to move on to a different example using the same library. In fact, I'm just going to steal that. I want to use the same library, but I'm going to use a different data set. And so save as, and it needs to be in the same folder because I'm using the same library. Tech diversity.py. And we're going to use this other library function, get diversity data. And that's going to take a CSV file, tech diversity.csv. I believe that's the name of the file. And I want to save it so we can run it and get it. And so we're going to call this library function. We're going to grab that data, which is another CSV file in here in my folder. Let's see, there's tech diversity CSV right there. And you can see that it has slightly different data. Company names, percentage of Hispanic, percentage of white, percentage of black, percent of Asian, percentage of total females, white female percentage, Asian female, underrepresented minorities, people of color, etc. It's just a lot of demographic data for these various companies. However, this library is not going to return a list of dictionaries. No, it's actually going to create a dictionary of dictionaries. So now we're going to get a dictionary of dictionaries. And so using this data set, we can actually look up a particular category. You can say how many Hispanic people, and we can then do calculations. Like, for example, let's average out the number of Hispanic people for all these companies in one data set. And we can do Hispanic companies combined. We can look for the average number of white people or black people as well, just to kind of give an average percentage. I don't want to run this, but I mean, let's go ahead and run it. But if I try to print this, I'm going to get a squeeze 85 lines. If I click it, I get a ton of data again. So not so helpful, but you can tell that now it's a dictionary here. And then this is the NVIDIA is the first value is its own dictionary of stuff. So we have, and then Pinterest. And Pinterest is another dictionary of values for Pinterest. And then Salesforce has its own dictionary. Okay. Oh, running out of time really fast. Okay, let's try to write this one fairly quick. So I don't really want to go through all that again. We looked at some company data, but I want to just write this method real fast. Get average percent of a category overall. We're going to get all the companies, not just one specific company. So I need to get the average for all the companies. So remember, dictionary of dictionaries. So let's say, for example, I want to get the average of all the companies for Hispanic population over all the companies. So we have to iterate over our tech diversity data, and that's going to give us the keys. And since we have a key now, diversity data, we can look and remember that key is going to return a dictionary when we provide the key. So now we're getting a dictionary, and that dictionary is basically one of these rows. So we have all these keys up here we can use, which is the category that's being passed in. So that's going to give us access to it, but now we want to sum it all together. So total 0, and then we just add them all together and return our total. And if that was the wrong command. When we run it, and let's look for Hispanic. Oh, that's not the average percent, is it? That's the total. How do I get the average? Well, there's a length function. Remember the length function? The length function gives you the length of the dictionary, which is going to then divide our total by the length, which is going to give us an average. So the average of Hispanics in all those companies is 5.9. Not very high. What about Black? 4.2. White, 57.7. Asian, 29.4. And we can look at other categories as well. Let's look at, there's one in there for total females. And I misspelt it, so let me go look and actually steal it. Total female, there was no S. 33.6. So not a lot of females. By the way, this is a real issue in tech companies in general, is right now we have huge diversity issues. It's not just things at the university, but in tech itself. And it's kind of a crisis where we have so many different, obviously we have so many different ethnicities, but they're not really well represented. You can see majority, 60% is white, with 67% being male. And then if you add up Asian and white, you're looking at 86%. So who's being represented by these companies? Very few people. And then they develop products. And when they develop these products, you're going to be biased by who developed them. So it's actually an important problem of getting more women, getting more people of color and different ethnicities involved in computer science, because we need more people. And hopefully you've all experienced the fact that this isn't like super hard, right? Other people should be involved in this. And unfortunately, most people think that it's mostly for white people, it's mostly for men, and it's not true, right? It's not. We can use more points of view, because that'll make better products and make better companies. And remember, this is a dictionary, so I can access like the demographics for Facebook, and I can actually see Facebook is 51% white. What else is Facebook? Facebook has 31.7. Actually, Facebook has less than the average number of females. We could look at Google. Google, in fact, let's look at Google again, but let's look at the number of Black people in Google. Remember, it's a dictionary of dictionaries. So 2.4% Black, which is less than the average. 5.2 Hispanic, which is less than the average. And we already looked, let's look at total female for Google. 29.2, which is also slightly less than the average. I think it was, what was the average total female? 33, it was less than the average. So Google's actually less than average on all of those. But we've seen now how we can use CSV files. We can get real world data, or we can create our own data. We don't need to know how the library works. We just need to know how the functions work. All we have to understand is how to call the function. Pass a file name, and you either get a dictionary a list of dictionaries or you get a dictionary of dictionaries, depending on which function you're using, right? You just have to understand the output and the inputs for these two functions. And that's how you access CSV data. And once you know how to use CSV data, you can do data analysis on large data sets. And you can use real world data sets. And like I say, I do a number of analysis and stuff for programming with CSV files just for my classes, just because all my data is in CSVs.